Hello, everybody, my marketing research fans and students. It's Dr. G. Hey, today we have our final analysis of Titanic data using logistic regression, and we are going to be using Python code to help us do the analysis, which is amazing. And similarly to the correlation that we did last time, there's a couple things that we need to do to get up and running to make sure our code will work. So let's get started here. Remember, this is the final worksheet out of 3 that you have for the assignment. The first was descriptives, of which we did pivot tables in good old-fashioned Excel. The second thing is we looked at correlation between variables. And now this time we're doing logistic regression. Now tell me, just to remind you what logistic regression is, logistic regression is when you have one of two options. It's like good or bad, dead or living, right or wrong. There's only 2 options. And because the Titanic, you survived or you didn't survive, we are going to use a logistic regression to determine the log likelihood of people are living or dying. I know it sounds kind of creepy, but actually it works out pretty well. Okay, so back to my screen sharing here. If you recall, these particular documents are located in the analyzing database or the analyzing assignment. And they also have the cheat sheets down here under module 11. So open up the logistic regression with Python file. I have it open right here. And a couple of reminders. What we're going to have to do is recall, if you haven't already, but I'm pretty sure you have, because this is number 3, you are going to input the Titanic CSV file into your Google Drive. Make sure that it is in your My Drive, because that's the only way our code will run, because we need to direct it to the right location. So what we're going to do is we are going to go back into Colab or colab.google. I think it's just, there's no .com on there, colab.google. And then you're going to click on new notebook. So let's do that now. There's my colab.google new notebook. Now I want you to name your file. I don't have it on here. I want you to name this file Titanic _ logistic. And then that would be a regression. So that's what you're going to name it. So you're going to go into here, see how it's untitled there? We're going to sneak right in here and go, I'm going to do test logistic. You're going to put Titanic _ logistic. I already have one of those, so I don't want to mess it up. So that's it. Go back to your handy dandy worksheet. And here, if you recall from correlation, one of the things we have to do is we have to import the libraries. So this time in the blue code here, the first thing we have to do is we have to tell Python the libraries we need. Like we want logistic regression, we want we might do a little bit of correlation, whatever it is, all those libraries are going to be loaded in. So copy and paste right there. Remember, we hit go, and go tells us if we've done a good job and we've gotten our code correct. We should get a green check mark. Voila, there it is. If you had an error, you would get an error. And there's nifty ways you can figure out how to fix the errors. I cheat and I go into ChatGPT because they've got amazing AI on how to fix code. So that's the first thing you do, load the files. And then what we're going to do next is we're going to read in our data file. So remember, we had to have this absolutely perfect when we did correlation. And if you don't have your Titanic CSV file under your My Drive in Google Drive, it will not work. So make sure you do that. We are going to add some code, paste that in there. And see, this is my content name. If we were trying to do logistic regression on a different, say, for example, the survey, your research project, you could load in that particular document in here and run the code. That's what's groovy about all this stuff. We get to reuse it. Okay, okay, it's going to ask us for it again. That's always a good sign when they're asking us for where our document is. It means it's going to load it in there for us. And if we do a good job and we don't have any misspellings with our file path name, we're going to get a nice check mark, and there we have it. So remember, just like last time, it's going to give it a snippet of the first few rows so we can look at it and make sure that it's all handy dandy looking good to go. So that said, we've got everything loaded in and ready to roll. So now we're going to do some preliminary analysis, just like we did last time in correlation. Let's just make sure that things seem to be working okay in terms of our data. So go back into Colab, paste the blue code that I had in there, and we should get a nice chart. So look at this. This time, remember last time we looked at things like passenger class and male versus female, etc. What we're looking at here is just pure passenger class, whether they lived or died. So we analyze that in the correlation, but what I want you to do again, just for good measure, copy it. So I know that you know what you're doing and you've done it. And you're going to paste it right there for me so I can see it. So, you know, it looks similar to the previous analysis that we did. So we've done a lot of looking at descriptive statistics. All right, we want to try to do some predictions now, looking at the odds of things happening. So in order for us to do logistic regression, there's a couple of things that we have to do. We did this with their correlation as well. You need to add code, and what we're doing here is we're telling Python to drop anything that has a null value. Again, this is something that you can't do in Excel. We got the green check mark, so we're good to go. So we've told it we don't want to look at any of the records with the nulls. So then the next thing, whoopsie, the next thing we're going to do is we are going to copy this code here. Something looks a bit awry there, but we can fix that later on, hopefully. We're going to copy this code. And that worked. So we're telling it we want to do logistic regression. So it's getting our model set up. The next thing we want to do, we've already done this. I'm not quite sure why we got this on there. I'll fix that later. So we want to understand the models now. So let's go in and look at the odds of surviving. And we're going to do that by copying this code here. And again, you can add your code, run it. What this is giving us right here sorry, I'm looking at my my notes. What this is looking at here is it's giving us the coefficients that allow us to see the odds or the log odds of an event happening. So for instance, in our model, we can look at the odds of survival change in different ticket classes. And so what we're doing here is we are interpreting right here the odds of living or dying. So right here we have what's called this output that we have here is the coefficients that were obtained from our logistic regression model. So we've got a coefficient of 0.47 and we have one of negative 0.52. So what is this telling us? So in logistic regression, these coefficients are used to calculate the log odds of an outcome. So we're looking at survival in this case, and we're basing it on predictor variables. So the predictor variable that we looked at was, the first one that we looked at is class, so passenger class. So we want to look at second class versus third class passengers, because remember, we knew that a lot of the first class passengers, there was a high core, we looked at some counts and a good number of them survived, but there were a lot of third class passengers and second class passengers that didn't make it. So what we're looking at here is that the first coefficient, the 0.47, corresponds to the coefficient of the second class. So what we did when we looked at the three classes is we dropped first class so we could just look at the coefficient of the second and the third classes. So we have in this case, we have a positive coefficient, which means that the increase in value of this feature, being second class or the variable, leads to an increase in the odds of survival. So that's second class. So we're looking at, if you're in second class, if you're going from third class to second class, that's your odds of survival going up a class. Now, the second coefficient, which is the negative 0.52, corresponds to the third class. Now, a negative coefficient means that an increase in the value or the variable being the third class leads to a decrease in the odds of survival. So let's say you were in first class or in this class. If you were in second class and you went to a lower class cabin, your odds of survival decrease. So that is how you, in summary, that's how you look at these. So the second class is associated with a higher likelihood of survival, and being in the third class is associated with a lower likelihood of survival. So again, we're looking at odds when we look at logistic regression. So let's kind of evaluate our model here. So we know, you're better off in second class than you are in third, right? So we are going to do what's called a confusion matrix. Yeah, I'm kind of hoping you're not confused right now. I tell you, don't do this stuff every day. It's not the easiest stuff in the world or the most intuitive. So we are going to do a confusion matrix. So copy that code, hit your button there, and we have a little table here. What this table is telling us is the sort of the wellness or the goodness of our model. So a coefficient or a confusion matrix indicates that the model, our model, correctly predicted 123 instances of survivors. Those are true positives. So it predicted our model correctly, 123. But incorrectly, 59. So when you're looking at that, so that's what we call a false positive. So when you're looking at that, you're looking at, let's see here, we've got 59 false positives. So we inaccurately predicted that. We have 123 true positives, meaning that they lived. And then we've got 0 true negatives and 0 false negatives. So we're looking at this is telling us how good our model is. So let's go back to our so you're going to paste the confusion matrix here. I'm sorry, I confused myself by not pasting the confusion matrix. Confusion matrix, I'm going to I don't need the other garbage at the bottom. Here we go. So I'm going back to my spreadsheet. I'm going to paste this in here. Right there. And see, you can see here, here's our numbers, a 0, meaning a 0. We have 0 true negatives and we have 0 false negatives, and we have 59 true positives and 103 true and 123 true positives, forgive me, and 59 false positives. So you are going to complete the matrix here with those numbers. So remember, so we also are looking at the predictors. So if you go up here, my confusion matrix, let's go back up here. Why am I not seeing my numbers? I'm so sorry. Let's go back into here because I didn't paste them. So let's look at here. So remember, this is our predictors. So of the second class, we have 47, 0.47, and in third class, we have a coefficient of negative 0.52. So you're going to place those right here, and I want you to interpret that for me. So if you're watching this video, you're gonna have a little cheat sheet. So as I mentioned, an increase in class leads to the odds of survival. So if you have, if you are in second class, you have a log odds of 47, 0.47 survival positive. If you float down to third class, no pun intended, you are having a log odds of negative 0.52. So what does this mean? So remember, we have here, you are going to put in your false negatives and your false positives into the matrix here. So we had 59 we had 59 false positives. We had 0 false negatives, and we had 123 true positives. So if you look at this model, what it is telling us is that right here, we have a 60%, 68% precision, meaning our model is good. We have we positively predicted 68% of the passengers. So what I want you to think about when you look at that, so if you were on the Titanic and you knew that, maybe I'm going to try to get to the second class, or I'm going to book a third class, our model is telling us 68% log odds that the second class is going to be correct. So I want you to think about that. So if you were going to purchase a ticket on the Titanic in advance, you knew it was going to sink. If you were to predict whether or not you're going to live or die, I'd take a chance of 68% as opposed, because it's higher than 50%. The odds are greater, right? But that's just my opinion. I probably wouldn't buy a ticket in hindsight, but there's some adventure seekers out there. So that is logistic regression. So for your Titanic assignments, yay, you're done, ships ahoy. You are ready to turn in your descriptives with the pivot tables, that worksheet, the correlation with this super cool correlation heat map, and the logistic with their confusion, the log odds, and your interpretation. I also want to see your work on the Excel file that you did. So four things you're uploading into the assignment, and congratulations, you made it through Titanic. Now, why is this important? Guess what? You've just built 3 models. And from those models, we're going to be able to take your survey data that you're collecting now for your research project, and we are going to be able to use those models in Python to run your predictions and your correlations. Now, one thing I will say is we did not do linear regression in the Titanic because we were looking at lived or died. That's a binary, only 2 variables. Most of you have scales in your data for your surveys, like a 5-point Likert scale, like, super sucks to amazing, 5 points. We are going to use a linear regression, and I will show you that model when we get to analyzing your data. So congratulations to all of you. I'll see you. Upload all 4 documents. You're good to go. Thank you so much, and out. We'll see you next time. Take care, everybody.